Section 4.2, solving systems of equations by the addition method. Okay, so the method of addition, we have these steps. So first, rewrite each equation in standard form, ax plus by equals c. Then, if necessary, multiply one or both equations by a non-zero number so that the coefficients of a chosen variable in the system are opposites. That means that if my coefficient in my first equation is 3 for my x, on the second equation, it should be negative 3x. Then we add the equations. We find the value of one variable by solving the resulting equation from step 3. Then we find the value of the second variable by replacing the value found in step 4 into either of the original equations. And then we check our solution for the system. So for example, A, we have 3x minus y equal to 0 and 2x plus y equal to 5. If you notice, my coefficients for the y's are already opposites. This one is negative 1, and for the second equation is positive 1. So we can go ahead and add the equations. So 2x plus 3x, that's going to be 5x. Negative y plus y is 0 equals to 0 plus 5 is 5. We solve for x, so we divide 5 on both sides. X equals to 1. Now that we've found the value of x, we can substitute in any of the two equations to find the value of y. So we have 2x plus y equal to 5. So 2 times x, but x is 1, plus y equal to 5. 2 times 1 is 2, plus y equals to 5. Subtract 2 on both sides. So y equals to 5 minus 2, 3. So we have the value for x and the value for 3. So my solution is 1, 3. So let's go ahead and check the solution. We have 3x minus y equal to 0. So 3 times 1 minus 3 equal to 0. 3 minus 3 is equal to 0. Yes. Now for the second one, we have 2 times 1 plus 3 equal to 5. This is 2 plus 3 equal to 5. 2 plus 3 is 5. 5 equals to 5. Yes. So our solution is correct. For example B, we have 6x minus 3y equals to 9 and negative 8x plus 5y equals to 11. We can either cancel the x or cancel the y. If we notice, x in both my equations, one has a positive, one has a negative, and the same for the y's. So we're going to go ahead and try to cancel the y's. So we're going to multiply this first equation by 5. Y by 5, it came from here. So by 5. And the second equation by 3. Y by 3, it came from the first equation from the coefficient of y. All right, so let's go ahead and do that. So we have 5 times 6x is 30x. 5 times negative 3y is negative 15y equals to 9 times 5 is 45. And then we have 3 times negative 8x is negative 24x. 3 times positive 5y is 15y equals to negative 11 times 3 is negative 33. Now here our y's have the same coefficient, opposite signs. So we can go ahead and add our equations. 30x minus 24x is 6x. Negative 15y plus 15y, they cancel. And 45 minus 33 is 12. So we solve for x, divide both sides by 6. X equals to 2. We go ahead and plug in that value of x in either of my original equations. So we have 6 times x, but now we know that x is 2 minus 3y equals to 9. So 6 times 2 is 12. Minus 3y equal to 9. Subtract 12 on both sides. So negative 3y equals to negative 3. Divide both sides by negative 3. So y equals to positive 1. So we have x and y. That means that my solution here, remember, it's an order pair. So my solution is 2, comma 1. We check our solution in both of my original equations. So check. We have 6 times x, but x is 2. So 6 times 2 minus 3 times y equals to 9. 6 times 2 is 12. Minus 3 times 1 is 3 equals 9. 12 minus 3, 9. 9 equals to 9. Yes. We check on the second one. So we have negative 8 times 2 plus 5 times 1 equals to negative 11. Negative 8 times 2 is negative 16. Plus 5 equals minus 11. Negative 16 plus 5 is negative 11 equal to negative 11. Yes, so the solution is correct. Example C. 3x minus 2y equals to 1 and 9x minus 6y equals to 3. So here, remember, you need to multiply by a non-zero number so that the coefficients of a chosen variable are opposites. I'm going to go ahead and multiply the first equation by negative 3. Why by negative 3? If I multiply negative 3 times 3, that's going to give me negative 9, which is the opposite of positive 9. So multiply the first one by negative 3. So times negative 3, negative 3 times this one. So we use the distributive property. Negative 3 times 3x is negative 9x. Negative 3 times negative 2y is positive 6y equal to 1 times negative 3 is negative 3. And nothing happened to the second equation, so we're just going to rewrite it exactly the same. And then we can add. Negative 9x plus 9x is 0. 6y minus 6y is 0, so we have 0 equal to negative 3 plus 3 is also 0. Now we check our statement. Is 0 equal to 0? Yes. Since this is a true statement, that means that my solution for this particular system is infinite many solutions.